All right, so the first unit in Math 10 is on something called relations and functions. All right, so and this very first lesson, which is titled Representing Relations, yeah, it's kind of like an introductory on the whole concept of what a relation is. So yeah, so let's just get right into it. All right, so first off, I want to just go over a few definitions. All right. So first one here is a set. All right. So a set is a collection of distinct objects. So the keyword here is distinct. So it means that the objects are different. All right. And you'll see an example as we get into the examples. What a little more clarity in terms of the what we mean by distinct objects. All right. But anyways, a set is a collection of distinct objects. All right. An element of a set is one object in the set. All right. So going back to this first definition where it says distinct objects, it it could be also said that they're distinct elements. All right. So basically, an element is one of those objects. Now, the concept that we're going to be looking at, excuse me, is a relation. Okay, so a relation associates the elements of one set with the elements of another set. All right, so when you're dealing with two sets, there may be a way to associate one set with the other, and that is called a relation. All right, cool. So this may be a little bit more clear once we get through the first example. I think there's two examples for today. All right, so there are different ways to represent a relation. All right, so we can use a table. We can use a, an arrow diagram, and we can also use ordered pairs. Now I just realized that actually. Just get this in. There's one more way that you're going to see here in this lesson. So I'm just going to punch that in here. We can also use bar graphs. Okay. So that'll come up in the second example, but I just realized that I put that in there, so I'll do that right now. All right. So anyways, the four ways to represent a relation, we can use a table, we use an arrow diagram, we can use something called ordered pairs, and we can also use bar graphs. All right. So I'm going to show you these in the examples. All right. So let's take a look at the first example. All right. So fruits can be associated with their colors. Consider the relation represented by this table. Okay. So this is again just one of the ways to show. First one here, show a relation. Is we've got one set, which is the fruit. The other set is the color. So, so for example, an apple can be red. An apple can also be green. Blueberries are blue. Cherries are red, and huckleberries are also blue. So these are the possible colors of each one of these fruits. So again, this is the first set. Color is the second set, and these are all elements, right? So I have an apple, blueberry, cherry, huckleberry. So when it comes to elements, the fruit here, we actually have, even though there's 5 listed, we only have 4 distinct objects, so therefore we have 4 elements. And likewise in the color here, you'll notice that we have red, green, blue, but then we had red and blue repeating. So there's only 3 elements in this color set, right? Because there's 3 different colors, right? A couple of them repeat. All right, so 3 elements here, 4 elements there. All right, so first thing we want to do here is we want to describe the relation in words. All right, so how can I associate the fruit? What words can I use to associate the fruit with its color? All right, so apples can be red, apples can be green. All right, so it doesn't mean that all apples are red, because they can be green as well. So the key here is that if I want to write the relation, we can use the association. Notations here may have the color. All right, so apples may have the color red. Apples may have the color green. Blueberries may have the color blue. Cherries may have the color red. Huckleberries may have the color red. So yeah, so when you want to just relate one set to the other, this works here, right? It may have the color. All right, so that's a relation. All right, so now a different way of A different way of represent relation is with what this, the other type here is called an ordered pairs. All right. So, or a set of ordered pairs. All right. So ordered pairs, you may have seen them before in terms of math. Just kind of go back to this kind of on the side. I believe you were taught this. Let's say I wanted to graph the point 5,1. Now this doesn't really have much to do with this example because we're dealing with words here or objects, but I'm just kind of jogging your memory in terms of what an ordered pair is. So this perhaps or hopefully looks familiar, right? We're going to review this more once we get to the mathy part of this functions and relations, but I just want to kind of jog your memory, right? This is your x, this is your y. So this relates, if I wanted to graph it, your x, your y, right? You'd plot a point right there because this would be 5, this would be 1. So for every 5, if I want to plot it, the y value here is 1. Therefore, that point there would be the graph, right? So this is an ordered pair. We could do the same thing here with these relations when it has to do with objects, right? So one ordered pair here would be like apple is my first word, and then it's related to red. So that's one ordered pair. We can also write apple, green, blueberry, blue, cherry, red, and the last one there is huckleberry, blue. All right. Now the other thing is just this kind of like notation thing, but we want to write it as a set. So we're just going to write this whole other thing as a set. So technically, there's another set of like squiggly brackets. So we just want to contain this all these 5 ordered pairs inside a set. So that's what it means by a set. Is just it's just notation really. I think that you've seen those squiggly brackets. All right. So this is the set of ordered pairs that shows the relation between the fruit and the color that it might be. All right, so those are ordered pairs. The other way, or another way of expressing a relation is something called an arrow diagram. All right, so for this, what I'm going to do is I'm just going to draw 2 circles. And in the first set here, or first circle, I'm going to write out the elements of the first set. Right, so there's an apple, blueberry, cherry, and huckleberry. Right, and in the second circle, I'm going to write the elements of the colors. So that would be red, green, and blue. Right, so you'll notice that, I didn't write red again or blue again because they've already been written down. Right, so we just want distinct objects, or we just want the elements, we're just going to write it down once. All right, so up top here, before I start connecting these things, I'm just gonna have to write kind of like the main idea in terms of relation, which is if I scroll up here to the part A here, describe the relation of words, we wrote may have the color. Right? So above this arrow, I'm just gonna write may have the color. And then with each one of these fruits, I'm just gonna connect it with an arrow of the possibilities, right? So apples can be red or green. Blueberries can only be blue. Cherries are only red, and huckleberries are blue. Okay, so this is how the arrow diagram is going to look. Right. So key thing here is, you have just the elements, so just write them down once. However, you may have 2 arrows, right? Or you might have, 2 arrows either going to 2 different colors, or you might have 2 arrows pointing at the same color, like blueberry and huckleberry. All right, which is fine. All right, but you only want to write these elements once. So that would be an arrow diagram. Cool. All right, so hopefully that makes sense. Scroll down to the next one here. All right, so this is another relation. All right, so different breeds of dogs may be associated with their mean heights. All right, just a little bit of technicality or definition here. Mean here, the word mean, you may not have realized it, but this mean height is seen as average. So their average height. Consider the relation represented by this graph, represent the relation as a table or as an arrow diagram. All right, so this is a graph, right, bar graph. So that's why I added it in. Go back up here. That's why I added it in as a way to represent a relation. All right, so so the mean heights of different breeds of dogs. All right, so this is your relation. We have breeds of dogs, and we also have their average height. All right, so first thing here, we want to represent it as a table. All right, so I'm going to do that over here. Okay, so part A as a table. So down the first column, I'm going to have the breed. And second column here, I'm going to have the average or the mean height. All right, so let's just start listing off the different breeds. So I have Afghan Hound, Chihuahua, Corgi, Golden Retriever, German Shepherd, and I don't know, heard of that, Malamute. Malamute, I don't know. Okay, so anyways, that's sixth dog there. All right, and on the side here, on the next column here, I'm going to write the mean height. So if I look up Afghan Hound, it looks like the average height here is 75 centimeters. 75 centimeters. Chihuahua, 20. Corgi is 30. Golden Retriever looks like it's 60. As well, the German Shepherd is 60. And the Malamute here is 65, it looks like. All right. Yeah. All right. So that here is the table that we can express the relation. All right. Part B. Arrow diagram. All right. So we did that. We did an arrow diagram in the previous example, but we'll do this one as well. All right. So for part B, diagram. All right. So draw some big circles. All right, so the different breeds were Afghan, Chihuahua, Corgi, Golden Retriever, German Shepherd, and a Bella. All right, and then on this side here, let me just kind of scroll it up here. We have the different heights. So 75, 20, 30. 60 twice, but I'm going to write it once, right? And 65. All right, so, and again, we want to lay out what the actual association is, right? So, so up top here, we're going to have these dogs. Each dog has a mean height. of, all right, and now we just connect them. So the Afghan hound, so the only one that repeats is the golden retriever. Both are 60 centimeters. All right, so Afghan hound, 75, Chihuahua, 20, Corgi, 30, golden retriever, 60, German Shepherd is also 60, and the Malamute is 65 centimeters. All right, so that is your arrow diagram. One thing I want to point out too is that it doesn't matter what order you list these elements, right? I could have the Afghan hound, at the bottom if I want. I could have 20 centimeters on the bottom. It's just as long as the arrows match up, right? It just happened that I just wrote it in order that I saw it on the graph here. Right? But again, and as well, right? These are, they are in alphabetical order, but they don't necessarily have to be. You can scramble your table as long as the mean heights match up. Right? So same thing here. You can scramble the breeds, right? Doesn't have to be in alphabetical order at all. But just as long as you matched up with the arrows, the correct average height. All right. Cool. All right, guys. So that's just kind of the introduction to relations. All right, just the whole concept of what they are. Later on in this chapter, and we're going to actually do a little bit more in terms of like how it applies to math. Right? But this is just a kind of a general overview of the concept of relations. All right. Cool, guys. Cheers.